Today we're going to talk about what are called permutations and combinations. So these might be some new words for you. Permutation is an arrangement in which order is important. So it matters what order you put things in. All right. Sometimes order is important, sometimes it's not. It's a combination is an arrangement where the order is not important. So when this means something different now, we use P for probability. Today it's going to be permutations. So number of permutations from 5, you're choosing 2 things. This is the same thing, number of combinations from n, you're choosing x. This is kind of the little formula you're going to use, and we're going to learn about what this exclamation mark means. It don't mean you're just excited about saying it. So 4 factorial is how you read it. The exclamation mark is read factorial. It means 4 times 3 times 2 times 1. So 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So it's not really hard to do, it just takes some time. But we're going to be referring back to this formula here when we're doing combinations, and permutations aren't maybe quite as long to do. So let's see what we can do with these. Find these permutations. So the first one says we want to from 6 choose 2. So if I have 6 things in my hand and I walk up to you and say choose one, how many things do you have to choose from? Well, you would have 6. You've chosen one. Now if I go to someone else, how many things do they have to choose from? They have 5. So that would be there's a total of 30 ways you could just choose those. So you just make your choices and then multiply the 2 together. So how many permutations are there? If from 7 we're choosing 3 things. So the first choice you would have 7. Second choice you would have 6. Third choice you're going to have 5. 6 times 5 is 30. Times 3 would be 210. Now combinations, since the order doesn't matter, you have to eliminate some things. So we read it the same way. Number of permutation or number of combinations from 8 choose 4, but remember what we said. This is kind of the formula that we're going to use for this, where n and x represent these 2 numbers. It's going to be n factorial over x factorial times the quantity n minus x factorial. So we're going to kind of put their numbers in their place. So what is n in this problem, number 3? It's 8. So 8 factorial. Yes, you do have to write some things out. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All over x factorial. Well, in this case, the x is the second number, so 4 factorial. 4, 3, 2, 1. And what is n minus x? So in this case, it's 8 minus 4, which is 4. So another 4 factorial. 4, 3, 2, 1. Now, we really won't need the calculator on most of this because what can we do? 4, 3, 2, 1, those all cancel. 4 goes into 8 2 times. 3 goes into 6 2 times. 2 goes into 2 1 time. So we don't really have very much left. You should end up with 1 on the bottom, which we do, which we can forget about. So what do we have left on top? We have a 5, we have a 7, and we have a 2. I'm going to multiply 2 times 5 first, which that's a little easier. 10, and then get 70 when we multiply 10 by 7. So a lot of things to write, but not super hard. And if you're thinking ahead, you won't maybe have to write everything out. I'm going to kind of show you some of that here in a minute. So again, for this one, 12 combinations from 12, choose 3. So again, we need 12 factorial. So 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All over x factorial, which would be 3, 2, 1, multiplied, and then I guess I don't need my parentheses though, since I'm going to go just write it all out. So what is, I'm going to put my 12 and 3 in here, so 12 minus 3 would be 9, so I need 9 factorial. But what do I know is going to happen here? I'm not going to write all these out, because 9, 8, 7, 6, 5, 4, 3, 2, 1, those all cancel. So I'm left now to work with this part of it. 3 goes into 12 4 times. 4 goes in, or 2 goes into 4 2 times. So I'm left with 2 times 11, which is 22, times 10, which is 220. So there are 220 combinations that I could get when the order doesn't matter. Okay. First thing we're supposed to tell if it is a permutation or a combination. So ask yourself, does the order matter? And there's sometimes when the order might matter to you and it wouldn't matter to someone else. So I guess this is kind of a not always a one answer on this. So how many ways can 3 people be selected from a group of 7? Well, there isn't any prize or anything. It really doesn't matter what the order is. So this would probably be a combination. So how many are we choosing from? 7, and we're choosing 3. That would be how we would write it. And now it did say, then solve it, so you guys have enough room here to write. Maybe I have to write kind of small. Let's start over here. So 7, 6, 5, 4, 3, 2, 1. On the bottom I need 3, 2, 1. And 7 minus 3 I'm going to need 4, 3, 2, 1. So remember these are all going to cancel. So 3 times 2 is 6. Cancel it with that and I get 35. So hopefully you kind of look the shortcut I kind of took there. Anyways, can 11 photographs be arranged horizontally? So we're putting these 11 photographs in a straight line. Well, to you it might not matter, but somebody doing a decorating job or something like that, it might matter. So I would call it a permutation from 11 photographs. How many are we choosing? Well, we're choosing all 11 of them, aren't we? So this is really just then 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Using your calculator, you're going to get 39,916,800 ways you can arrange those. So lots of different ways when you have a lot of things like that that you are arranging.